Now let us see the next type of limits, that is limits of exponential and logarithmic functions. Here we have four standard results as shown here. That is, the first is limit of 1 plus x whole raised to 1 upon x as x tends to 0 is equal to e, and here we know that e is nothing but it's a number, it's a specific number which has the value approximately equal to 2.718. So basically e lies between 2 and 3, and we know that e is to be taken as the base of logarithm in calculus. So wherever we see the formulae involving logs, it is assumed that it is with the base e only, so there is no need to write that base every time. Now second limit is limit of a raised to x minus 1 whole upon x as x tends to 0 is log a. So here also log is with the base e. Now the special case of second is the formula number third. That is, if we write a as nothing but the constant e, because here a is to be taken as a constant. So if we write a with e, then the right hand side will actually become log of e, because the formula is log a here, but we know that log e will be nothing but equal to 1, so therefore that is what we get as right hand side. And lastly we have limit of log of 1 plus x whole upon x as x tends to 0 is equal to 1. Right, now let us solve few sums based on these results. Alright, here first we have to evaluate the limit of 3 raised to x minus 5 raised to x upon x. Now if we ask the question like which is the standard result to which this expression comes closer to, so we have just seen that the limit a raised to x minus 1 upon x and as x tends to 0 is given by log a, isn't it? So if we compare this formula with the required one, we can see that a raised to x terms are present here, that is 3 raised to x and 5 raised to x, but the minus 1 term which is required is not present. Now we can easily adjust that as, first let us write 3 raised to x minus 1, right? And taking minus common from the second term, we can write 5 raised to x inside the bracket, and we can have additional minus 1 inside the bracket, so that effectively we have not changed the value of the original expression, correct? So further on, splitting the given expression, we can write it as 3 raised to x minus 1 upon x minus 5 raised to x minus 1 upon x. So the limit of first particular expression from the standard result is nothing but log 3, and minus the limit of the second part is nothing but log 5. So we can see that log 3 minus log 5 is nothing but log of 3 upon 5 using the standard rule for the logarithms. So that is what the final answer. Let's go ahead and see another sum. Here we have to find the limit of this particular expression, right? Once again we are seeing the different terms of the type a raised to x, okay? Now if we think that with every term we must adjust minus 1, that is fine as far as numerator is considered, but in the denominator if you observe, we don't have just x but we have x squared. So it means that if we break that denominator as x into x, okay, in the numerator we must have one term as a raised to x minus 1, and denominator also we must have the term of the type b raised to x minus 1, so that we can use the standard limit on these particular two expressions. So in other words, it boils down to the fact that we have to factorize the numerator into two factors as shown here, right? So if we observe closely, we will find that it is not difficult to factorize that, and we will get the factors as 5 raised to x minus 1 into 2 raised to x minus 1 whole upon x square. Right? So therefore that is further equal to limit as x tends to 0, we have 5 raised to x minus 1 upon x into 2 raised to x minus 1 upon x. So that gives us the limit of first quantity is log 5. Now here it is the multiplication, so limit of the second quantity is log 2, and there is no further formula available for simplifying this expression, so log 5 into log 2 is to be kept as it is, right? So that is the final answer. Now let's see next question. Alright, here we have limit of 1 minus 3x upon 5 whole raised to 1 upon x as x tends to 0. So let us ask the question, that is, which is the standard result which comes closer to this? So if we recollect, we have one result that we saw in the standard results is limit of 1 plus x raised to 1 upon x as x tends to 0 is nothing but e, right? So the way we remember this result is we must have one term as 1, okay? Then whatever is the next term, its reciprocal must be present in the exponent, alright? And whatever is that second term x, the same term must tend to 0, okay? So now with this, let us try to rearrange the given limit in the required shape, right? So here we have 1 minus 3x upon 5. So if we observe with the standard limit, we must write the reciprocal of the term other than 1. So which is nothing but minus 5 upon 3x, isn't it the reciprocal of this term? But in doing so, we have actually changed the required expression, alright? In the exponent we have 1 upon x as given, but what we have written is minus 5 by 3. So therefore to correct it, we must write it as minus 3 by 5 multiplied to the index which we just wrote. So it is this particular expression. So simplifying that further, we can write this as 1 minus 3x whole upon 5 raised to minus 5 upon 3x whole raised to minus 3 upon 5. Correct? That is simply because a raised to b into c is same as a raised to b whole thing raised to c. Okay, so we are just writing in the same way. So now if you observe this curly bracket, it is exactly of the form which we want for using the standard formula, right? So therefore that is nothing but, we can take the limit of that particular quantity, that is nothing but limit of 1 minus 3x upon 5 whole raised to minus 5 upon 3x. Okay, this entire term will approach as x tends to 0 to e, and this whole thing is raised to the exponent of minus 3 by 5. So therefore the answer would be, the limit is nothing but e and raised to the outer index, that is nothing but minus 3 by 5. This is the final answer, right? So we use the formula in order to arrange the standard format. Now let's see one more example. here we have to evaluate the given limit involving log of 3 plus x minus log of 3 minus x whole upon x equal to what? So let us recollect that here we had seen the limit of log of 1 plus x whole upon x as x tends to 0 was 1, and we had also seen that if we have a limit of log of a function as x tends to something, then we can take log outside and take limit inside. So limit of log is nothing but log of the limit, provided that limit is positive. So keeping that in mind, let us try to solve this particular question. Alright, so here limit x tends to 0. The x in the denominator I will write separately, 1 upon x multiplied by. In the numerator we have the expression of the form log a minus log b. So that is log of a upon b, which gives us log of 3 plus x upon 3 minus x. Correct? So that further gives us limit x tends to 0. Now we have limit and we have log, but right now we cannot take log as it is because we have this intervening term 1 upon x. So to get rid of that 1 upon x which is sitting between limit and log, we can send that term as an exponent of that particular expression whose log is taken. So it is nothing but log of 3 plus x whole upon 3 minus x raised to 1 upon x, and we are taking the log of this whole quantity, and then limit is taken of this particular log. Now we can definitely take log outside. I mean, we can take the log of limit now, that is limit of x tends to 0. Now in the meantime we observe that the particular expression that we have inside the inner bracket is 3 plus x upon 3 minus x raised to 1 upon x. So this also seems to be of the standard form, but then if you recollect, in the standard form we have the expression as 1 plus x raised to 1 upon x. So that 1 is a crucial term, we must adjust that 1. Now to do that we can simply divide both numerator and denominator by 3. So what we are left with is 1 plus x by 3 upon 1 minus x by 3, and this whole thing raised to 1 upon x, right? Alright, so moving ahead we have this equal to log of. Now we can break the two limits, that is limit x tends to 0. In the numerator let us write it as 1 plus x by 3. Now for the standard limit we must have the reciprocal of x by 3, which is 3 by x, but what we are given is 1 by x. So that means the factor of 3 we have added on our own, so we must multiply by 1 by 3 to keep the balance, and whole thing divided by limit x tends to 0. Similar to numerator we will have the denominator as 1 upon x minus 3, right? Now here the reciprocal is minus 3 upon x, so therefore we will have to multiply with minus 1 upon 3. So that gives us log. So here writing that as limit of 1 plus x by 3 whole raised to 3 by x, and this entire quantity raised to 1 by 3 divided by the limit in the denominator is limit of 1 minus x by 3 whole raised to minus 3 by x, and this limit is raised to minus 1 by 3. So simplifying that further we have log of. Now if we see the limit in the numerator is the standard result, which is e. Of course I forgot to write its limit as x tends to 0. So it's clear that as x tends to 0, obviously x plus 3 will tend to 0 as well as minus x plus 3 will also tend to 0. So that gives us the limit of the square bracket as e, and this is having the index as 1 by 3 whole divided by, in the denominator also we have the limit as e, but its index is minus 1 by 3. So that is nothing but 1 by 3 and minus 1 by 3 will get subtracted. So 1 by 3 plus 1 by 3 is 2 by 3. And we know the exponentiation and logarithmic operations will nullify each other, giving us the final answer as 2 by 3. So that is the required limit.